Here we have a Dell laptop that came in for no power, and the laptop looks something like this. I looked up the service tag number, and the model of this laptop is, I got it somewhere right here. This is the Inspiron 15-inch, model 5579. The customer included this paper. He has a printout of one portion of the motherboard, and he has this arrow pointing to this one area. Update. This is where the MOSFET that supposedly was shorted goes. I do not know how the customer knew that component is shorted. I do not know if we still have that component on the board. But he also wrote, when I picked up the computer, it looks like this computer was taken to another repair shop. They had already soldered a new MOSFET, but the short circuit on the motherboard continues. So it looks like the shop replaced the MOSFET, but the motherboard still has short circuit. And Big Boss already removed the motherboard, but I want to see where that component the customer is talking about is. I'm looking for this big circle here. Right there. We have a MOSFET on top, and this one looks missing, but I do see a MOSFET here. Two of them next to each other, and I do see that diode right over here. So let's take a look at this area and see what's going on. And yeah, I do see where that MOSFET is, right there. So it looks like the shop worked on this MOSFET, but the customer wrote in the paper that there's still a short. Let's start by fixing this MOSFET. The soldering does not look good. So the first thing I want to do is fix the MOSFET. We're going to remove that MOSFET completely. I just want to make sure the MOSFET is soldered on properly. Let's check the legs here. And all those pins are connected as one. So the MOSFET, the orientation of the MOSFET should be like this. Let's make sure that we have enough solder on those pads. All right, and now we can solder that MOSFET. And now comes the measuring part. Let's go ahead and measure to see if we have a short. Meter in diode mode. Fume extractor off. 0.6. That's healthy. Very good. We do not have a short on gate. OL. And we're going to have OL here. The gate is OL, and we have a short. We have a short right here on those three pins. Right now we know that we have a short on this side of the MOSFET. Maybe we can move the camera a bit like this. Now we know that we have a short right here. We have a current sense resistor here, just like the previous video that we did. We have two routes. We have a bottom route, and we have a dead end here, and we have an upper route. If we go through this upper route, I mean, that route extends all the way to right side of the board. Now look at this, it wraps all around the board. We have a capacitor here. Is the short coming from this capacitor? It's possible, we do not know. What else? We have this route right here. And we have two MOSFETs here. And we have another route. I mean, the route goes all over the board. We have a lot of components on the board, and the short could be coming from any one of those components. How can we tell which component is causing the problem? We're going to inject voltage and monitor the board under a thermal cam. Right now, we're going to be using our voltage injection tool, and I have it set at 1.5 volts and maximum amps We're gonna set it at maybe 6 or 7 amps. Okay, 6. What we're gonna do is connect ground to any one of the screw holes here, right there. And now we're gonna inject voltage at the short, at the MOSFET. Let's take a look. I'm gonna inject voltage right over here. We're gonna be injecting 1.5 volts. But of course, before we inject voltage, we need to point our thermal camera on the board so that when we inject voltage, we can monitor and see what gets hot on the board. Right now, our thermal camera is pointing at the board, and the MOSFET with the short is right over here. 1, 2, 3. What's getting hot on the board? When I pointed the probe onto the MOSFET, our voltage injection tool showed us 5 amp draw. So we know that we have a short on the board somewhere. But we want to monitor and see what gets hot on the board. Let's do this one more time. I'm going to point the probe at the MOSFET, and let's see what's getting hot on the board. Oh, right there, right there. My hand was covering this area, so I did not see it. Let's try this one more time. And I want to make sure my hand is not sitting on top of this area. Right there, look at this heat spot. Look at this. But it looks like the short is not coming from top of the board because heat looks diffused. What I did is I injected voltage right here at the shorted MOSFET, and something heated up right here. So as you can see, if you have a short here, it doesn't mean that you have a problem in this area of the board. A short here could be caused by something all the way far end of the board. So heat is coming from this area of the board right here. And I do not think that a small cap like this is going to cause a 5 amp short. So let's flip the board and see what's going on here. Right there, that's more like it. We have big caps here. And we have an IC. The short is likely coming from any one of those 3 caps or possibly the IC. What are we going to do? How can we tell where the short is coming from? Well, the first thing I want to do is measure those caps in diode mode and see if in fact we have a short here. And you see, we have a short. And all those capacitors are connected in parallel, and all of them are connected to that chip, and we have a short here. So the short is likely coming from any one of those caps or the chip itself. What we're going to do is start removing the caps one by one. We're going to eliminate them one by one and see where the short is coming from. Let's start with the first one here. Right now we have a short on all 3 of them because all of them are connected in parallel. If the short is not coming from any one of those caps, then likely the short is coming from that chip. And my hot tweezer is off. Let me turn it on and try this again. All right. Let's see if we still have a short. Meter in diode mode. And short is gone. Look at this. Wow, short is gone. We figured out the problem. Let's go under the microscope. Before, all 3 caps were measuring a short, and right now we no longer have a short. Look at this. And if we flip that board and measure that MOSFET one more time, we should no longer have a short on this MOSFET. And the short is gone. We are measuring 0.4 voltage drop. That's it. The board is fixed. The board is fixed. Let's get rid of that capacitor completely. And like I mentioned in the previous video, we're going to replace that capacitor so we can save the world from complaints. Because some people will comment and say, how come you did not replace that capacitor? This is a bypass capacitor, and the laptop will still function if it's off. I'm going to desolder this one. We're going to measure the value of this capacitor, and we're going to replace it with a similar value, or at least close to this value. Let's put it right over here like this. I do not want to lose it. And we're going to use our LCR meter to measure the value. We're going to go to capacitance mode right here, and let's measure that capacitor. 9.2 microfarads. Same as the laptop that we worked on yesterday, same value. No problem. My dad just left and I told him to lock the door because I do not want to be interrupted anymore. I want to finish this video in peace. Let's go ahead and solder this cap back. All right, and now we need to grab another 10 microfarads capacitor. And just like that. Very nice. Let's go with this one more time. The job is done. I had a few comments yesterday where a few viewers were asking, how can we possibly find out where the short is coming from if we do not have a voltage injection tool or a thermal cam? I mean, it's tough. Right now, short is coming from this side of the board. And the component that is causing the short is all the way down here, back of the board, right here. How can you possibly tell that there's a component here that is causing a short here? Some even asked, can we use alcohol to find out where the short is coming from? If you are injecting voltage here, how can you put alcohol on this side of the board? Unless you can find a common point where you can inject voltage here and then drop alcohol on the whole board and see what evaporates first. And one other common question people are asking is, do we have to have a voltage injection tool or can we use our power supply? You can use your power supply if you want, but I do not want to risk damaging my $300-400 power supply when I can use something that's meant for that purpose. This voltage injection power supply is all heatsink. It's meant for that purpose. And it's very easy to use. Dial to change the voltage, press on that dial, dial to change current. That's it. I'm almost always at 1.5 volts, 1.2 volts, but this voltage injection power supply can go up all the way to what, 15 volts? So you can go up to 15.3 volts. If I press on that dial, how far can we go up on current? 20 amps. 20 amps. I'm almost always at maybe 5 amps, 6 amps, maybe 7 amps, but I never have to go up to 20 amps. Compact, easy to use, and it's all heatsink. It's meant for that purpose. So if you want to use your own power supply, go ahead and do it. But I would recommend having a voltage injection tool when dealing with short circuit. All we have to do right now is reassemble the motherboard and test. Big Boss already left, so I'm gonna have to do this on my own. I connected the power jack. I'm currently connecting the screen. LVDS connector. I do not want to wait for Big Boss to reassemble this tomorrow because I want to finish the video right now. Screen is connected. This cable is connected, this cable is connected, and let's connect the keyboard. I do not know if the power button is on the keyboard or not, but let's connect it anyway. And the battery is connected. Anything else? I think we should be able to test the laptop by connecting the battery, the keyboard, power jack cable, LVDS connector, and I'm not going to connect the hard drive. I do not care about the hard drive right now. I do not know if the battery has any charge in it. And the power button is not part of the keyboard, so the power button must be somewhere And yes, laptop is working. Amazing, amazing. The job is done. I'm gonna leave this on Big Boss's desk so he can finish the reassembly. We're gonna invoice and mail this back to the customer.